Yeah, I should get that uploading. Yeah, rather than Web 3, I think we should call it Cloud 3, with Cloud 1.0 being basically um, this idea where whatever the gateway is, of course you're going to have servers, gateway servers, but the gateway into the cloud mainly means that you've abstracted and you don't really need to know what hardware or servers or whatever um, the computing's actually being run on. Yeah, it's got to be, but that's what the cloud management software does, right? Brings you in as a user, gets what you need to be connected up to, connects you up to it in a virtual sense, in that you don't need to know what's going on behind the scenes. That's Cloud 1.0. Cloud 2.0, I would say, would be our current state of virtualization, where, and what people usually think, clouds these days, that is like Microsoft Azure, Google Cloud 9 Home, or Cloud 9, I should say, Amazon's AWS, and there's a lot of other vendors and players trying to make it in this market too, that aren't the big data platforms, but they're well, of course, the most obvious thing. The thing is they're just virtualizing networks and computers. So if you're used to doing it with hardware, internet technology networks and hardware, now you can make it just virtually within the cloud, and you don't need to have hardware. Now, the big cost benefit questions I need to have researched and answer, actually, is a regular thing. Is the cost benefit there? Is it cheaper to have a virtual network with virtual computers and servers within a virtualization cloud? Or is it actually cheaper to buy the hardware, buy the HR personnel, and get a T1 line onto the internet, and just physically have it as well? Kind of leaning towards, I sure hope it's cheaper to use the cloud services, because then from there I would actually, this is kind of more advanced, but I eventually want to see if we can make our main net on a virtual network. And if we can do that, um, wow, we could just crank out things that are very, very high value. So I would call that Cloud 2.0. Now, Web 3.0 being kind of parallel, if not analogous, to Web 3, I'd say Cloud 3.0 is this new paradigm I'm talking about, where a cloud is a network of nodes. But now it's kind of recursive, because a node could be another network or cloud or platform. Um, I've always loved systems integration, and this new paradigm, that's what we're talking about, is systems integration. So if you're new to my recordings, I will redundantly go over the new way of doing computing, which is called mock webhooks. MOC stands for microservices. APA stands for API first, which enables the power of integration. And C is cloud native, which is really where the paradigm breaking is. And H is for headless applications, which, okay, that's just saying don't have your D apps worry about presentation layer. Leave that to some other service. Um, And then webhooks, incredibly powerful as a systems developer, uh, because often going calling APIs, you're reduced down to having to use a polling mechanism that, like, say, every 5 minutes, every hour, every day, every month, whatever, checks in with the API and says, "Okay, this is the data set I want. What do you got for me?" Or, "We're already set up for. I'm already subscribed to this data set. Give me the fresh data." But the side that has the API typically doesn't have the ability to call back, which is what a webhook is, as a callback function, and say, "Hey, you signed up for this." And I mean, a crude way you can do it with email systems or message systems, which is maybe a first pass proof of concept way of implementing things. But for that service, for that API to say, "Hey, you subscribe to this data set, and I've got a new one." And this is particularly helpful if you've got systems you're interacting with that maybe every hour you check, but the data probably only meaningfully changes or as much as you need to care, like, say, every day. So, 24 times you're checking, and it's not very likely there'll be anything fresh and new for you. We won't start talking about real-time systems here, which is something wholly other. So the subscription thing would be, I say, "Okay, let me know when there's a data change," and so nothing happens there. The calling program can go about its business, do whatever it's going to do, and not be blocked. Might have a deadly embrace. It helps avoid deadly embraces too. But so then, the API says, "Oh, I got a data change. I'll send a packet out to you because you signed up to be subscribed for this." Um, Very powerful, very powerful, and very desirability for scalability of the system. So Cloud 3.0 isn't even, it's not directly about blockchain. It's not directly about encryption. What it's about, it's not even about smart contracts, really. Smart contracts is just the technology that's getting implemented these days. But rather, it's about this new computing machine we have available to us. And the thing is smart agents. No one smart agent does the whole job. So how do we get a swarm of agents to coordinate in such a way that, as some kind of a higher level unit, they get the job done? They can function, they can do what they're supposed to do. Um, because it's antithesis to the mock webhook architecture to say, "Oh, we're going to have one D app, and that D app does it all." Monolithic scalability, "Oh, we want a bigger app? Well, we just make a bigger D app." No, see, that's the old way. You got to stop thinking like that. You want to get an idea of the potential for my business plan. I'd tell you a little parable, I think. Think along the lines of Henry Ford's Model T assembly line and what that did for the automobile industry. Think in terms of Thomas Edison and electricity. And sure, we know he invented the light bulb and a bunch of other cool stuff. But you know what? In the 1920s, people were inventing stuff with his electricity, using his electricity as, you might say, a platform, uh, and making all kinds of things that used electricity. Most of them are ubiquitous and we don't even think about them. For us, they've been around two or three generations, two generations. But but how big did electrical devices become? That'd be an interesting contest to hold sometime. Have people name how many electrical devices can they name? God, never mind the innovation of the transistor. You know, everything in our computing world these days comes down to the transistor, or what we in the electronic IT world would call a flip flop. You need to have a flip flop in a computing system or you can't get anywhere. You can't do anything with it. It's kind of like the old Dilbert joke. I like, what was that, Wally or whatever that said, when I started programming, we only used zeros. I got to explain to you, it's not a joke. Though the first microcomputer I worked on, it is true we only had capital letters, and our huge old dot matrix printer could only do capital letters. So, anyhow.